Hello. This problem discusses what is the magnetic field due to a current carrying wire that is square in shape. The basic idea is that the square is built out of four line segments carrying wire, each one carrying a current I. So if we know how to calculate the current due to one of the wires, that's the same idea repeated four times, and we have to add them vectorially. Let's do for one of the wires and then we repeat the idea. So this is, let's say, a zoomed out expression for side one here. Let's say that's side one, that's side two, so that's side three, and that's side four. This is the observation point P, and the basic idea is that this is length L over 2 here. This is length L over 2. Overall, this length L, that's length L over 2. And this is also length L over 2. I'll write that in a minute. So the current is going to the right. So that's my initial point. So that will be my theta 1, but that is to the left of the observation point. So I had to go back in here. So that's theta 1, which should be measured as a negative angle. This side here is L over 2. Let me write that down here. And this is theta 2. Theta 2 will be positive and theta 1 is negative. The expression for the magnetic field due to this configuration is, in general, written as B is equal to phi hat, which is got by using the right rule. In this case, if I were to hold the wire with the thumb pointing in the direction of the current, the curls at point P goes into the page. So phi hat is the tangent to the circle at point P. And this is mu naught over 4 pi. It's proportional to the current I and inversely proportional to distance r. In this case, it is L by 2, which I will. So let's say this is L over 2. Let me make it very general here and later write that as L over 2. In general, it is some distance r, and this will be sine of theta 2 minus of sine of theta 1. And one should realize that this is a negative angle. Negative. Which, if we avoid this confusion of it being negative, this can be written as I over distance r. This is sine of theta 2. And if it is negative and negative, in this case, in this particular scenario, is theta 1. One should be careful when interpreting this as minus or plus. I've taken care of the fact that theta 1 is not to the left in this formula that made that possible. In our case, for B1, so for segment 1, theta 2 is pi by 4, which is 45 degrees, and theta 1 is equal to minus pi by 4. Thus leads to magnetic field due to segment 1. Let's say this is X hat, that's Y hat, and Z hat will be coming out of the page then. And in that case, it is going into the page, so that's minus Z hat. Minus Z hat here means that it's going into the page. It's mu naught over 4 pi current I, and the distance between the point P and the wire is half the length, so it's L over 2. And sine of pi by 4 is 1 over root 2, and it is plus here cos of sine of pi by 4 again, which is 1 over root 2. Or if we think of it as negative, then it is negative of negative 1 over root 2. So that's overall minus z hat mu naught over 4 pi times as a factor of 2 over root 2, and L over 2 also contributes a 2. So it's overall I over L times 4 over root 2. That's B1. B2 is exactly the same thing. Again, it will be pointing inward. So B2 will come out to be exactly B1. In fact, all four of them point into the boat, into the page, and they have exactly the same expression at point P because of the symmetry of the square. And that's B4. So total magnetic field at the center of the square is B1 plus B2 plus B3 plus B4. So B2 plus B3 plus B4. It is going into the whiteboard, which is minus z hat in the coordinate system expressed here. And it is, since it's 4 times identical expression of B1, so this will be mu naught over 4 pi I over L, the L being the side of the square, and 4 times 4 over root 2, so it's 16 over root 2. If I use 2 over root 2 as root 2, so it's 8 times root 2. If we have the numerical numbers, one can evaluate this magnetic field, and we say that it is going into the page at point P. But we are only asked to find an analytic expression for this. So that finishes this problem. Let me stop sharing the screen and stop recording.